Hi, this is a quick review for section 2.1. So 2.1 is about the instantaneous rate of change. So the idea is that from chapter 1 we learn about the direct rate of change or the slope formula. So given a function on the xy, now the direct rate of change is just the changing rise over run between any 2 points on the function or on the graph of f of x. Like in this case, this point and this point, we take the rise over run, and using the slope formula delta y, the changing in y over the changing in x, you should get the direct rate of change. But now in this section we learn about the instantaneous rate of change. For this case, we are also given the same type of the graph function, but now we only look at one point. How fast is this function is changing at this one specific point. We are not considering for any other 2 points like in the previous case, but we only consider the changing of the function at this one particular point, and that is called the instantaneous rate of change of the function. And that is also the definition of the derivative or f prime of the function. So the derivative is just the instantaneous rate of change of the functions at any particular point of the functions. And we got the formula as we discussed in the class for f prime as the limit f of x plus h minus f of x over h as h is approaching to 0. And the reason why, you can take a look at the other cases here. The reason that we got the limit definition or the slope formula of just one point, f prime in this case, because now if you imagine I have the function f of x, this is the x-axis, this is the y-axis. Now, before we use the slope formula to find the direct rate of change between 2 points, but now we only want to find the rate of change as one particular point. We cannot apply the slope formula unless we have 2 points in order to find the rise over run. Therefore, to find the rate of changes at this one point, I use another point to the right of that or to the left of that, but just to make it easy, I use one point to the right of that, and then I find the rise over run ratio, or I just use the normal slope formula and then I find the direct rate of change. But the thing is, I pick the other point very close to that point. I just pick the a larger distance so you can see it easily on the picture, but eventually you want to pick the second point that is very close to the point that you are solving for the f prime, and that is the reason we got h to be approaching to 0, because the distance between the point x and x plus h, the distance h between them, now you want that to be very small as much as possible. So I want h to be approaching to 0, and that's why in this limit formula here you want the h to be approaching to 0, because the h is the distance between the point x and x plus h. Now at the point x, I have the function, the y value is f of x. As the point x plus h, I got the y value to be f of x plus h. Now I can still use the slope formula rise over run. Now rise is the higher value f of x plus h right here, subtract the lower point or f of x is right here, and then dividing by x2 or x plus h minus x1 or x, And now from here we can see x and x they cancel, so you have h at the bottom, and f of x plus h minus f of x. Make sure that the limit is always h approaching to 0, and this is the instantaneous rate of change of the function as 1 point x, and that is the derivative function of the f of x. So for one example, we are given a function f of x equal 2x squared plus 1. Now the question is asking you to find f prime of 1. Now f prime of 1 is the instantaneous rate of change of the function when x is equal to 1, or finding the derivative function when the value of x is equal to 1. So how do I do that? There are two ways we can do it for now. First, you can just finding the general formula for f prime of x, and then do the substitution of 1 to x, and that is the answer. Or you can using the slope formula, but you need to pick another point very close to number 1. Now let's try both ways, and you should see the same answers. Okay, so let's try the first way. So the first way, I'm finding f prime, and by finding f prime, I have to use the limit definition right here. F prime is equal to the limit of h approaching to 0, f of x plus h minus f of x over h. Now we can apply that here. So I use I'm choosing the first method here. So let's do that here. So f prime first, and then do the substitution of x to be 1, and then you got the f prime of 1 here. So the f prime of x is the limit as h approaching to 0, f of x plus h minus f of x over h. H is the distance between the 2 points. Now we was given the function f of x, right? So f of x here is 2x squared plus 1, but we did not have the value of f of x plus h. So let's try to find f of x plus h. So remember, this is f of x. F of x is 2x squared plus 1. Now f of x plus h is the composite function of this function right here. So how do I find f of x plus h? Well, it's actually easy. Anywhere you see the x now become x plus h, because the function f now is the function of x plus h. So anywhere in the original function you see x now becomes x plus h. So 2 is right here. I keep that 2. X now become x plus h, and then square, and then carry the 1 to here. And now we have to do the simplification. Remember, this is the square of the binomial. So remember, we have the formula a plus b squared, that's equal to a squared plus 2 times ab plus b squared. So I can do simplification right here. So I have 2 x squared plus 2 times ab, so plus 2 times x times h, 2xh, and plus h squared, the last term square, and then plus 1. And I can simplify that further. 2 times x squared, 2x squared, 2 times 2, that is become 4xh, and 2 times h squared, that's 2h squared, and plus 1. So now this whole expression right here is the value for f of h x plus h. So I go ahead and rewrite here, limit h approaching to 0. And now this whole thing here is this whole expression we just found on the upper right corner right here. So that 2x squared plus 4 xh plus 2h squared plus 1. Now subtract, carry the subtraction. F of x was given a 2x squared plus 1. So put that inside the parentheses because there's subtraction in the front over h. And now it's time for algebra simplification of that. We still have to carry out this one here. Now, when I move the subtraction minus 2x squared, there's a plus 2x squared and minus 2x squared. So this term gone and this term is gone. Okay, this is plus 1 minus plus 1 is minus 1. So this 1 here and minus 1 here is also gone. So on the top we have 4xh plus 2h squared over h. And we can see there's the h factor, there's the h factor. So I can factor out the h term because I want to cancel the h at the bottom. So I pull out the h on the top. I have 4x left. I have 1x h left. And then now we can see the h term and h term they are cancelled. So all you have left is the limit of h approaching to 0, and then 4x plus 2h. When h is approaching to 0, so h now becomes 0. 2 times 0 is 0. So at the end you just have 4x as the final answer for your f prime of x. But the question doesn't ask you for f prime of x. It's asked for f prime of 1. So all you have to do now is plug in 1 for x. So f prime of 1, x is 1. So 4x is 4 times 1 because this is 1 for x. 4 times 1 is 4. So f prime of 1, the value is go to 4. Now that is the long way we have to follow. And in chapter 3 there should be a shortcut to find the derivative function of f prime of x, and then that should speed up the process. But for now you have to apply the whole limit definition to find f prime of x and then plug in the value of x to find that f prime. Now this is the way that we use for the limit definition in general, and it's very nice because once you figure out f prime of x, the general formula for f prime of x, you can then find any value of f prime at any point of x just by plug in the value of x. It can be 1, 2, minus 1, 5, 10, any value of x, because we already have the formula for x. So you just plug in the value of x to find any point for the instantaneous rate of change because you have the general formula. However, if you didn't follow this way and using the slope formula, we can end up with the same similar values 4. So if I use the slope formula, let's try another page here. If I use the slope formula, I must have 2 points because I'm looking for f prime of 1. That means I want to find the rate of change at a point of 1, but we cannot apply the slope formula if we have just 1 point. Therefore, I have to pick 1 point after 1, but very close to 1. So 1 go to 1.0001. So 1.0001 is very close to 1 because we just want to find a value at 1 only. Therefore, we pick another point. It's also very close to 1. Now I have 2 points. I can find the changing in the y over the changing in the x because this is the the slope formula, the rate of change slope formula. So f prime of 1. Now the changing in the y, that means the changing in the f value. So that means f of the second point 1.0001 subtract the changing, that means subtraction, f of 1, because we are changing from 1 to there. So that one subtract f of 1. And then the changing in the x-axis. So we go from 1 to 1.0001. So therefore 1.0001 subtract 1. This is the rise over run or the slope formula. And now we got the f function f of x was given a 2x squared plus 1. So f of 1.001, this is the value of x. So all you have to do is substitute this value here to the place of x, because this is the function of f. So f of 1.0001 is 1.0001 square plus 1. I've just plugged in the value of 1.001 to the place of x here. And then subtract f of 1. So I plug in 1 to the x. So that is 2 times 1 square plus 1. And then over 1.001 minus 1. And that should equal to 0.0001. Now, if let me try to plug in this into the calculator. Okay, so so here 1.001 square. So let's try that. 1.001 square. And multiply that by 2, and then add 1 to that. That should give me around 3.0004, and that is 2 times 1, 1 square is 1, 1 times 2 is 2, 2 plus 1, 3, so minus 3 over 0.0001. And now let's do the subtraction. 3.0004 subtract 3, that is 0.000004 divided by 0.0001, and that should give you 4. So we also got f prime of 1 equal to 4, and that is the same thing as I got earlier right here. So the two answers are the same. One is using the approximation of the slope formula, but make sure the 2 points are very close to each other, and then apply the rise over run. Or you have to find the general formula f prime of x by using the limit definition, and then once you get the general formula, you just have to find the value at a specific x equal 1 by the substitution of x to the function you got for f prime of x. Okay, so that is how we can find f prime of something by using the limit definition or by slope formula. And the derivative is just the instantaneous rate of change at one single point only. And the slope is the average rate of change of 2 points of the function. Alright, thanks for watching.